Hi children and hi everyone. In previous video I uploaded 3 activities videos. I performed 3 activities regarding the refraction of light. So how the light is refracted, that should be explained with the help of 3 activities I uploaded in the previous video. Up to now you didn't watch that one, just go and watch the videos, then only after come to this video. Clear? So children, now today in today's video I am going to explain how the refraction takes place. So refraction is the one of the property of light. What is mean by refraction? How the refracted ray behaves when it is moving from one medium to the another medium. So children, in general, here today our topic is what? Chapter is refraction of light at plane surface, at plane surfaces. Children, here we are taken now, this is the one glass beaker is there. In that you can keep some coin. Clear? So you have to watch the coin from the top view clearly. So this is the now one horizontal table. On the table you have to keep, I already explained this activity there in previous video. Here this is the empty glass beaker we have taken, a glass vessel. In the bottom what you have to keep? One 5 rupees coin you have to keep, and you must be watch the coin at this point, and after that you have to move some distance from the table up to where you are not possible to see the coin. So you are taking one beaker, in that you have to keep one coin. The coin is at the bottom of the glass beaker and you must be kept on your table. Initially when you are close to the beaker you must be able to see the coin. Slowly you have to move away from the beaker up to where we are not possible to view the coin. Just you can stop there. Initially this is the glass beaker and the coin is the bottom. When we are very close to the beaker we are able to see the coin from the top view, and after that we have to move at some distance. So here now in this position, now you are unable to see the coin, and then other case you have to suggest your friend pour some water into the beaker. Clear? Up to here. Clear? So then you can observe that whether you are able to see the coin or not. Yes, we are able to see the coin. Here you may get the same coin image at this location, then you are able to see the coin from the top view also. Clear? What's the difference? What's happening there? Let us discuss. So initially when we are very close to the beaker we are able to see the coin. When we are far away from the beaker we are unable to see the coin. If you can pour the water into the beaker, again we are able to see the coin. So what's happening, what's phenomena there? Let us clearly explain in this one. In this video I am going to explain very clearly the topic. Just watch it. So children, you must watch the video without skipping any portion of the content. Clear? So children, now here what is mean by refraction of light? Refraction of light. So here we have one word, it is there, medium. What is medium? Now in which medium you are learning the subject? English medium. So here English is a language that can help to you learn about the subject. That's why you are studying in 9th class in English medium. Clear? In the same way, to move the light, some medium is helpful. In which medium, in which substance that should be going to be moved. that is called medium. The substance which can allow the light through them, they can be acts as a medium. Clear? So now in this case, generally in case of, here we have to discuss one thing is what? Fermat principle. Fermat principle is there. According to that, the light is always selected. For example, this is the one point and this is the one point, and here if the light is coming from this one, the light must be select a shortest path. Light here, source is there, so we can imagine this light should be most like this, light should be most like this, but this is the path, this is the first path and this is the second path and this is the third path. Here the source is there, from that light rays are coming. Here this is the first point A, I am saying that this is the second point B. Now the light wants to go from A to B, light wants to go from A to B. Clear? If you can imagine that this is the one path of the light ray and this is the another path of the light ray and this is the another path of the light ray. In these three, which is shortest? The third ray, what I am telling, that is the shortest path. Shortest path. That's why in this, got my point? Here light is, here some source is there, the light is wants to move from A to B. A to B. From, we have, if you can imagine so many paths like this. Here this is the third one is the shortest path, A to B. So first one is like this and second one is like this, third one is like that. That means the light should be transmitted in the form of straight line paths to reach the one point to the another point in the short path. So according to that principle, the light is having some straight line path nature. Clear? That is generally what we call rectilinear propagation of light. So that's why here when the light is moving from one medium to the another medium, it must be obeys the Fermat's principles. Clear? Now here generally this is the one interface, what it is called? Interface. And above this one we have some medium 1, it is there, and this is the medium 2. I already told you what is medium. Medium is nothing but which can allow the light, that should be taken as medium. Clear? Now the light ray is coming from medium 1. Medium 1. Clear children? The light ray is coming from medium 1. So this is the incident ray. What do you call? Incident ray. Incident ray. And that now the interface is nothing but here the surface which can separate the both media, which can separate the both media, that should be called here interface. Now at this point the ray is again going back to the same medium, going back to the same medium. The incident ray is incident at point on the interface. That point is generally what we call point of incidence. What we call? Point of incidence. And after that, that should be what I am telling, that should be completely going back. Completely going back. That means that now what's happening? This is what? Reflected ray. Reflected ray. Clear children? This is the, just imagine, just watch here carefully. This is the interface. What is interface? Which can separate the two media, that is the interface. And this is the incident ray. That should be incident at this point. That point, what I am telling, point of incidence. So after that, the same ray is going into the same medium. This is the medium 1. Incident ray is in the first medium and reflected ray also in second medium. That means after incident, the ray is going back into the same medium. That phenomena is called reflection of light. What we call? Reflection of light. When the light is moving from one medium to the another medium, after incidence, the incident ray is again going back into the same medium as reflected ray. That phenomena what we call reflection of light. Clear? Reflection of light. Clear children? at this point here I am drawing here one normal. This line is what? Normal line. So at the point of incidence you have to take the normal line. So this is the normal line and this is the incident ray. This is what? Incident ray, and this is what? Normal. The angle between these two is called angle of incidence. What we call? Angle of incidence. Clear? And this is the normal and this is the reflected ray. Now it is called angle of reflection. What is smaller angle of R is what we call angle of reflection. What we call, children? Angle of reflection. Clear? So this is about the reflection of light. Reflection of light. So now we can go for refraction of light. Refraction of light. Again same thing here. This is what? Interface. Interface nothing but it is a straight line. So here again this is what? Incident ray. Incident ray. This is what we call point of incidence. Point of incidence. So now here again this is what? Medium 1 and this is what? Medium 2. Medium 2. Here this is what? Incident ray. This is what we call point of incidence. So after that at the point of incidence, while the ray is moving from medium 1 to medium 2, while, watch carefully at the diagram, this is the medium 1 incident ray and this is the medium 2 refracted ray. Now at the point of incident there should be bends. While it is entered into the another medium there should be bends. That phenomena is called refraction of light. Refraction of light. When the light ray is moving from one medium to the another medium, at the points of at the interface there is some bending of light should be takes place. That means there is some change in its path. Change in its path will be there. That should be what we call refraction of light. So generally if there is no bending, simply this is the actual path of. So this is the incident ray. If there is no bending of light, simply that should be goes like this. So if there is no deviation, that should be goes like that. But here during this refraction there should be bends. The refracted ray should be bends. So now this is what we call a refracted ray. Refracted ray. And this is what? Incident ray. Incident ray. Got, children? So again I am telling, this is what? Normal. This is what, children? Normal. Angle between incident ray and normal, what we call angle of incidence. And this is the normal and this is what? Refracted ray. And now here what we call angle of refraction. So here angle of I is angle of incidence, angle of R is what we call angle of refraction. The angle between incident ray and normal is called angle of incidence. The angle between normal and refracted ray is called angle of refraction. Angle of refraction. So refraction means nothing but when the light is moving from one medium to the another medium, at the interface the bending of light should be takes place. That phenomena is called refraction of light. Children, you must know about the difference between the reflection of light and refraction of light. So you must watch clearly here. So what I am telling, this is the medium 1 and this is the medium 2. What you observe, this is the incident ray and now this is the reflected ray. So this is the angle of I and this is the angle of R. Clear? So what you observe, in the case of reflection of light, the light is going back into the same medium 1. The light is going from one medium to the other medium. I am saying that at the interface the light is reflected back into the same medium. That is what we call reflection. What we call reflection. Now when in case of refraction of light, the medium is already going from one medium to the another medium, one medium to the another medium. That's why here the refraction is belongs to two media. The light is enter into the one medium to the another medium. But in case of reflection of light, the light should be in only one medium. That means incident ray and reflected ray both are in same medium. So that's the difference between reflection of light and refraction of light. In reflection of light, the light should be in only one medium. But in case of refraction of light, light is moving from one medium to the another medium. So angle of refraction means what? The angle between the normal line and refracted ray is called angle of refraction. Children, I think you may got clarity between the reflection of light and refraction of light. So now children, here you must know what I am telling. During the refraction of light, what you have to say? The light ray is bending. During the refraction of light ray, the light ray is bending. So that is phenomena what we call generally refraction of light. So here my question is, why the light ray is bending? So let us see here. So generally the medium which can allow the light, that should be divided into two types. Here the first thing is rarer medium. First thing is what? Rarer medium, and next thing is what? Denser medium. The light passes through so many substances, that's why they also called as mediums. Here when we will consider the medium, especially classified into two types, that is what? Rarer medium and denser medium. Clear children? In case of denser medium, the density is more. The medium which is having more density, that should be called denser medium. And the medium which has less density, for rarer medium density is less density, and for denser medium density is more. So don't forget children, these basics are very very important for lifelong when you are studying about the light. For rarer medium density is less, for denser medium density is more. The medium which has more density, that should be called denser medium, and the medium which has less denser, that should be taken as the rarer medium. Clear? The activities 3 I explained in the previous video. Why we are getting the letters were very very big in case of physics terms. While you are watching that video, you can understand now for those questions now we are getting the answers. Why we are finding that the coin is when we are finding the physics terms through a glass very clearly when there is no water, but when you fill the water with the glass, we are watching the terms physics will be very big size, and they should be in reverse manner. So once you can watch the previous video, you can easily understand what I am telling now. Okay, for those activities I am giving the answer now here. Clear? When, for example, what is meant by denser and rarer medium, already discussed just now. Here if you can take water and air, so air density is always less, that's why air should be taken as rarer medium and water should be taken as the denser medium. So air is taken as rarer medium and water should be taken as denser medium. And now in this case of glass and air, then air is rarer medium and glass is denser medium. So denser means nothing but density is more. When density is more, the particles are very crowded together. Okay, and now in this case, how the light ray is going to behave when it is moving from rarer to denser, denser to rarer. That's very very important children here. So these two things can give the correct answers for you. Now the first case I am taking here, light is from rarer to denser in this case. Clear? So that means what? Rarer to denser, rarer to denser. That means medium 1 is what? Now here rarer medium. What's that? Rarer medium. And medium 2 is what? Denser medium. Denser medium. Clear? Light is moving from rarer medium to the denser medium. So this is what? Interface. That is what? Interface. Clear? And now here the velocity of rarer medium is, first one is v1 and velocity is v2. Clear, children? So generally while we are moving in a vehicle, I am driving myself my car. Clear? When there is no traffic on the road, I will go very fastly. When there is very lot of traffic, I will go very less speed. That means road is same, but here what is the difference? Based upon the traffic, when there is no traffic, I am going with very speed. When there is traffic, less speed. Like that. In here, already know that what it is rarer medium. Rarer medium means what? Air. In air, the molecules are separated by more distances. That's why density is very less. When density is less, the speed is more. When density is less, speed is more. And in case of water, the molecules are close compared to the gases or air. In liquids, the molecules are separated by small distances. That means density of water is more than the density of air. Clear? It means that, children, my aim is to say simply the velocity of light. Same light will be moving with different velocities in different medium. Because while the light is moving in air, there is no obstruction by the molecules of air. Even though obstruction is there, that should be very less. While the light is moving through the air, the air molecules shows the lesser position to the light rays. That's why it is having more speed. But when the same light is passing through the water, the water can obstruct the moving of the light ray. That means speed should be decreases. So that means the speed of the light ray should be depends upon the density of the medium. Simply when density is less, speed is more. When density is more, speed is less. That means simply while the light ray is moving from one medium to the another medium, that should be bends. Because of change in velocities. That's why only the light ray can bends. Clear? That phenomena what we call refraction of light. When the light is moving from one medium to the another medium, due to change in velocities, the light rays are bent at the interface. That is because of refraction of light. Clear, children? So that's why here, watch carefully here. The rarer medium consists of velocity v1 and denser medium consists of the velocity v2. And now here I am drawing, this is the light ray. Clear? This is what? Incident ray. What is that? Incident ray. This is what? Incident ray. And this is the point of incidence. At the point of incidence, I am drawing here one normal. Draw some one normal. This is what we call angle of incidence. So now here I am drawing. This is the refracted ray. This is what? Refracted ray. And this is what? R. Angle of I. Angle of I is angle of incidence, and angle of R is what? Angle of refraction. So what you observe? In this case, angle of I is greater than angle of R. Angle of I is greater than angle of R. The light is moving from where to where? Rarer medium to the denser medium. That means after the refraction, the refracted ray is moving towards normal. Clear, children? So this is the reason why we are getting the different type of characteristics of images. When the light is moving from rarer medium to the denser medium, what you have to say? Angle of I is greater than angle of R, or angle of R is less than the angle of I. Angle of R is less than the angle of I. That means when the light ray is moving from rarer medium to the denser medium, after refraction, the refracted rays must be towards normal. Must be towards normal. That's why angle of R is must be less than the angle of incidence. So clear, children? So this is about the here. Angle of R is less than the angle of I. Clear, children? And now second case. What's that? In the first case, what do you say? Light ray is moving from rarer to denser. Now light is moving from denser to rarer. Denser to rarer. Denser to rarer. So here now, again this is what interface. This is what interface. Clear? This is what incident ray. This is what incident ray, and this is the point of incidence. At that point we have done some. This is what normal. This is what normal. Now in this case also the ray bends. The ray bends. So this is medium 1. Medium 1, it is what? Denser medium. This is what? Denser medium, and this is what? Rarer medium. Rarer medium. So this is what? Angle of I, and this is of angle of R. Then what do you observe, children? In this case, angle of I is less than angle of R. Angle of I is less than, here angle of incidence this is, and this is the angle of refraction. But here R, we can write this also same thing. Angle of R is greater than angle of I. Angle of R is greater than the angle of I. That's why the light ray is moving away. In this case, what I am telling, after refraction the light is towards the normal. In this case it is away from normal. Away from normal. After refraction, the refracted ray is moving away from the normal. So this is about the when the light is moving from denser medium to the rarer medium. When the light is moving from denser medium to the rarer medium, what you have to observe? The reflected ray is moving away from the normal. And when it is going from rarer to denser, moving towards the normal. In this case, angle of R is greater than angle of I. In this case, angle of I is greater than angle of R. So in previous video I uploaded, if you can take a glass beaker, in that you have to keep pencil. It seems to be very big. So when the glass is empty, and we have to keep some pencil, we are not finding any difference. Simply now inside it is empty, air is there, outside also air is there. That's why almost all there is no change in the size of the pencil. But when we can take the same glass that should be filled with some water, now the pencil should be, you can keep that. So you can find that below of the interface we can feel that there is the size very high, the size is very big. That is because why? Here water it is there. Water means what? Denser medium. Light is coming from denser medium to the outside, what you have? Air. That's why it is moving away from normal. Moving away from normal. So this is the glass, and up to here what we have? Water, and this is what? Air surface. This is the interface. Glass beaker is now it is the interface, and this is what side? What you have? Air. When the light is moving from denser to the water or rarer medium, moves away from the normal. That's why at this point it moves away from the normal. That's why we can feel that the size of the pencil is very big. Clear? So that's why children, you have to observe the while a fish in the water, it seems to be here. The person is who is the bank of the water. So the seen by the fish should be like this, denser medium to the rarer medium. While the person is above the bank of the water sources, then he was observing the should be like this phenomenon. So these two are the reasons for the why we are getting the different type of images during the refraction of light. Simply in this entire video we have to learn about the what is refraction of light and what is reflection of light and how the light should be refracted when it is moving from one medium to the another medium. So I hope you understand, children. So if you can understand this topic, like, share and comment the video and subscribe my channel for the latest notifications and press the bell icon, children. So I hope you understand, you enjoy my class. So we will meet in the next video with some other topic. Bye, take care, we will meet in the next video.